Gasoline direct injection, or GDI, is an increasingly prevalent drive system for passenger cars worldwide. The growing demand for low fuel consumption and stricter emissions limits calls for innovative engine concepts. In 2020, 1/4 of all vehicles worldwide will be equipped with GDI systems that create the air-fuel mixture right in the combustion chamber. This enables a higher compression ratio, thus improving efficiency. Torque and driving dynamics are increased, while emissions levels are reduced. An electronically regulated fuel pump located in the fuel tank provides the necessary amount of fuel to the high-pressure fuel system. The fuel is compressed by the high-pressure pump to the required pressure level of up to 2,900 psi and stored in the fuel rail. There, a high-pressure sensor measures the current pressure. Mounted on the fuel rail are high-pressure injectors that meter the fuel and spray it under high pressure right into the combustion chamber, where the spark ignites the air-fuel mixture. Bosch injectors with innovative, laser-drilled spray holes provide maximum flexibility and spray configuration while minimizing wall wetting in the combustion chamber. To achieve the best possible combustion during gasoline direct injection, the air-fuel mixture is created right inside the combustion chamber. Key components in the Bosch direct injection system are the electronic control unit and the high-pressure injector. Bosch offers controlled valve operation, or CVO, which provides an even higher level of precision over conventional direct injection fuel systems. A Bosch system using CVO uses the engine control unit to measure the activation signal and determine the opening and closing of the valve needle to compute the duration of the open phase. Thus, the electronic control unit can calculate the actual injection amount of every injection and readjust if necessary. When CVO is utilized, its closed-loop activation makes it possible to meter even the smallest injection amounts with minimal tolerances. The precision of the gasoline injection is thus significantly improved in this area and is maintained throughout the working life of the valve, guaranteeing a stable combustion process.